Alrighty then, it looks like we're good to get going. Um, Everyone, thank you so much for joining today. My name is Daniel Perlovsky, and I'm going to be taking you through some of the great new changes that we have coming out in Azure Data Factory this week. So, this session is going to be focusing primarily on mapping data flows. And mapping data flows is a feature within Azure Data Factory that's been GA for just about over a year now, or a little under a year. But it's been, being used by customers for about a year and a half. And we've been collecting a lot of feedback over the last year and a half and have figured out different ways to improve the product. Now, today's session is going to be focusing primarily on the derived column transformation and the expression building experience within the derived column expression. Now, we have a bunch of different new features that we want to show you and new experiences that we want to show you to really, show you some of the goodness that's coming out of this. So I'm going to go ahead and jump right in and build a bunch of different things within my data flows and just show you how it's done. So feel free to continue asking questions in the chat. My colleague Mark Cromer is going to be answering things. So just yeah, and I have the questions live as well. So if I have a sort of lull in anything, I will also go ahead and answer them. Great. So right now in front of me, I have a data flow with a single source that's pointing at some data I got from basketballreference.com. It's just simply the NBA player statistics from 2019. And I'm going to do a quick data preview here to show you what it looks like, just so we could understand the shape of the data that we're working with as we're building some of our different business logic here. And as this is loading, I'm going to go into the Inspect tab just to quickly show you the metadata of what I'm doing. So my data set has about 30 columns. It's a mix of strings, shorts, doubles, and these are all just essentially different basketball statistics of an individual player over the year 2019. Going to my data preview tab, we could see we just have a list of players here, their position, their age. Whether or not you're a basketball fan or not, it's not super important, but this is just some free data that I used because they let me use it. So let's go ahead and add a derived column. And what's nice is actually adding a derived column, still the same. You just click add and it goes to the screen. And let's call this derived column something good. Let's call it like, I don't know, get basketball data. Now, just right here, you may notice some at least UX changes. Now, first off, we have a bunch of commands now at the top bar. You could actually open the expression builder directly from this top bar here and also add new columns. But let's actually jump into the expression builder right after I show you one quick thing here. So say let's add a column 1. What we could do now is you could actually type in your expression directly into the text box here. So say I wanted this be equal to a hard-coded string test. I could just type this in here and it will be there. This will evaluate just as if though you opened up the expression builder. Now, while we still recommend using the expression builder for all the goodness it gives, and I'll demonstrate that in just 1 second, this is really useful when copying and pasting expressions, because I could go Control A, Control C, add a new column right here, and just paste the code right there. But I do want to dive directly into the expression builder itself and show you some of the different experiences there. So let's go ahead and open the expression builder just by clicking this Open Expression Builder button here. So for those of you that have used data flows a lot, this will likely look familiar but also slightly different. The first thing I do want to highlight here is that all of your expression elements now are below the expression instead of to the left of the expression. The reason we did this is a feature I'm about to get to in just a second called locals, along with some other new features that we have coming in down the pipeline, and just make our UX a little more extensible for more and more expression elements coming in. We also designed this in mind with users that want to, be able to easily build their expressions, have all the information that they need in front of them, use this derived column pane on the left to really be able to just create new columns and create new column patterns as well. But we'll get into that in just 1 second. You also may notice that now we could edit the column name within the expression builder itself. So let's call this column player name. And quickly jumping out of here right now, if you look at our source data, we see that our player name is the player name backslash and then a code to identify the player. But let's just say we want the name itself. So I'm going to split that string into an array and breaking it up by that backslash character, and then taking the first element there. If you've seen demos from me in the past, you know this is one of my favorite ways to break up strings. So here we're going to use the split function. Something else that's new is if you just highlight over a function, you actually get now all of the different things it does. So now I know the split function has these two parameters and splits a string based on a delimiter and returns an array of strings. So what we're going to want to do is we're going to want to split that string player, which is the player name, and do it based on the backslash character. Now something to keep in mind here, the backslash character needs to be escaped. That's why I have two backslashes. Those are just for special characters. It's not necessarily super important for the context of this demo. So what you still have here is you still have your ability to data preview an expression right in front of you. So you could just click refresh and see what this turns into. So something I've already realized is this expression is not just going to give me the player name. This is actually going to return an array because I did not get the first index of this. Here we could see this is our input column, and the output column is an array with two elements, the name and the code. So at least we know the splitting worked the way we want. So let's iterate on that and just take the first elements. Remember, data flows are index 1 based. So let's refresh that once again. And now we could see we have the player name that we want. So that's great and all. Now let's collapse this and get the full expression builder here as well. Let's say I want to use this player name, this context in multiple derived columns. Well, this is a relatively simple expression. Maybe I want to use it throughout multiple times. So what we could do now is we're going to go ahead and create what we call a local. Now, local variable allows you to essentially create a derived column that does not propagate down to other downstream transformations. So this is really, really useful if you want to reuse a code element in multiple derived columns, or if you just want to compartmentalize some of your logic. So, and I see a question there, is this available in the future? This is all landing this week. So you'll see all of this goodness by the end of the week. So to create a local, something you could do inline of a derived column, let's actually call this name. And let's just put the expression here. So a local can take in all the same thing derived column can, including parameters, including locals, and essentially it's just like a mini derived column. So let's create that there. Click and create, and now we can see the locals happen there. So now instead of just typing this in, I could just reference this local like this. And let's refresh this, and we should get the same exact preview here. So as this is loading, what I'm going to do next is then create a separate column that'll actually reuse the local as well. So this will take just 1 second, and and this is also adjustable as well. This is a new feature where you could adjust these to, make this expression preview fit your different needs. So I'm going to create a column, and I'm going to call this column describe a player. And there we can see the data preview did return what we expected. And I'm actually going to use what we call string interpolation, which has been there in the product for a bit, but is I think something people don't necessarily use enough because it's super useful, especially when doing something like a select statement in a source query of just typing out your string logic. So What string interpolation does is use double quotes instead of single quotes. And now I could actually reference things in line. So I could say name is a blank player, and that will actually evaluate to a string that says, okay, whatever that expression name evaluates into is a player. And what that player rating is, and so it says, yeah, you could save here on the top right, which will just allow you to cancel out and reopen this. This will do is we're going to create another local. We're going to call this player rating. And we're going to use a little more of a complex piece of code. So let's do a case statement. And what we're going to say, if a player scores less than 10 points, let's say they're a bad player. But if a player scores less than 20 points, they're a good player. Now, if someone scores 20 points or more, now that's a great player. So this is just a simple case statement, and I must have evaluated my logic wrong. Unable to parse expression. Why am I unable to parse this expression? Because I forgot a comma. So there you go. Now I have a valid case statement, and I'm happy with this. So let's create this. And now I could actually just use the local here. And it's a lot simpler of an expression to look like. It's like, okay, I'm looking at this. I know I have these variables. I could look at what evaluates into, and that's great. Also, you could create parameters inline as well. I'm not going to actually be doing that here, but that creation process is also here, and these parameters will show up in the standard parameters tab, separate from the derived column transformation, just in the general tab. So let's save and finish here, and let's do a quick data preview here just to see what that string interpolation evaluates to. So the difference between data preview is still the same as the difference between data preview and expression builder before, whereas this will actually show you the data that's transformed downstream. So you'll notice that if we go into and inspect, we now just have 2 new columns, even though we have 2 locals. Those do not get persisted down. Now if I scroll all the way to the right, I could see I have this column player name based on a local, and then I have a describe a player, which evaluates to what all of their different, are they a good player, are they a bad player, exclusively depending on their points per game here. Now, something I'm really, really excited to show you all is how we've improved the column pattern experience. Now, column patterns are a very powerful operation within Data Factory where you could work with columns that are either not defined in your input schema if you're using schema drift. We have some videos on that as well, or if you want to affect a bunch of different operations in bulk. Now, let me create new, and I'm going to create this column pattern right here. So you could create that inline here, and that's completely new. And first, I want to create my matching condition. Now, if you don't know what a matching condition, we got this nice little info icon here, but essentially, this is a Boolean expression, a true or false statement that's saying which columns am I applying a singular rule to. So what I want to do is I want to match on all columns that are of type double. And I see a quick question. Are there any performance differences between using locals and creating a derived column rather than doing subsequent derived column logic? There's no tangible performance differences. I would use whatever's most organized in your code. It'll be a lot better in the long run. So I'm matching on type equals double. And then I'm going to create my column name expression, my value expression. Now, column name is, okay, for every column that I'm matching, what do I want that column to be called? So I just want to update the column that's matched. So if I have a column of type double, I am going to update a new column. I see a couple more questions. Before locals, could expressions refer to other derived columns in the same activity? The answer to that was actually no. You cannot reference derived columns in the same activity. This is a brand new functionality. And does the local only exist in the specific activity you create in? The locals are in scope with the derived column, so you cannot reference them in any other derived columns. They are local to that transformation. So the value expression here is I just want to round these doubles. So if you notice, like you could average 16.8 points a game, but I'm only interested in round numbers because, decimals are just a bit tough. So let's round that matched column to no decimals, and I'm just gonna use the default rounding. So what I'm doing here is, and let me expand this out, is for every column that's of type double, oops, and let's have that save. I am updating the column name and then rounding that value to have no decimal points. So going back into data preview here, let's refresh it. It's loading. I also see a comment that local should help these long chains of derived column activities that I do for complex logic. Exactly. That's exactly what it does. And I also see a question, how can we check if a column returns null? Or if a lookup value doesn't exist, so return default value. Actually, I'm going to quickly jump back into that. There's an expression called, you can search here. So if you look at your null expressions, I believe it's called IIF null. So you could pretty much say, checks if the value is not null, and if it is null, you return something. If not, you return something else. So hopefully that'll clear things up there. And this will be a little more clear if I reduce that as well. So what was I trying to do? Yes, I was returning the data preview here just to show you. Now all of my different doubles all evaluate to 0. So I could see, okay, now blocks is 0.0, everything ends in 0.0, and going back into the inspect functionality, I could see now there's 23 columns and everything that's a column is updated. So that's awesome. That's great. I'm pretty excited about that. Now, what I'm going to do is go into some other transformations where this expression builder update also applies. So for example, in your source, say I want to parameterize allow schema drift. I actually can now do that again with the expression builder. I was able to do that before, but here we can actually see, should I validate schema? Maybe not the most accurate name, but that UX does exist there. And now let's go and add a select transformation here. So what if I'm only interested in a rule-based mapping. A rule-based mapping is essentially like a column pattern, but this is just affecting the metadata of the column. I'm essentially matching on a bunch of different columns, and if it meets that match condition, then I am going to change the name of that. So what I'm going to do is, if the origin, origin is actually a new thing that we have coming in, a new sort of metadata operation that we have. And let me actually remember what my origin is. So if my origin is this, and what an origin is did the column originate in a transformation? So what I'm doing here is, if I want to connect to apply something that affects the all columns that are created in get basketball data, and let's say we just want to do something simple like make all those column uppercase. Let's see what that looks like. So because that's my only mapping rule, that's the only thing that is mapped, and everything that was not created there, so everything that may have been a type short was dropped. So now going into inspect, we could see everything that was created there, just the doubles and the two columns that are created are what persists, and everything is of all caps. We could also confirm that in data preview. I see a question about connection to SharePoint. I don't think we'll have time to get to that today, unfortunately, but we have some documentation there, and if you message me offline, either via LinkedIn, I could connect you with the individual that'll be the best person for that. So as this is loading, we'd see now everything is here and everything is completely all caps as expected. And these updates apply for all transformations. So I have a filter on, I get this new expression builder that now has all the expression builders I could use in this context. Works the same with join expression columns as well. So that's kind of all I have to show you all today. Hopefully this was helpful. Hopefully this explains some of the new UX changes that are coming in. We're going to continue to iterate on this to continue improving your developer productivity. We have some other changes coming down the pipeline as well to make you, if you have maybe more complex data flows with lots of different transformations, we're going to improve that in the future as well. Just stay tuned on this YouTube page, stay tuned on our Twitter channel, on our Microsoft Tech Community blog, and feel free to answer questions in the chat. I'm here to take a look at them and answer them. So I'll stay on for about 5 more minutes to do that. Notice the difference of evaluations depending on the data type of the field of the coalesce function. Yes, the data type of the field often does affect how a function works. I would say look at the function reference, either look inline. So if I go to a derived column here, you could actually go to the function reference and see what's going on there. And you could see, okay, if this is the element, what's actually happening. Let me reduce this. So I can see, okay, given all these inputs, this is what's happening. So let's go to coalesce. Great, now I know it'll just do the first non-string. But yeah, other than that, just feel free to answer questions in the chat or reach out offline. Let me know if anyone has any questions. Never made data flow work to load multiple data sources, say by some foreign key. Can you maybe elaborate on that? To add multiple data sources, it is really quite easy. You just kind of click and add as many sources as you want. If I want to reduce this. Where can we send money to have this feature available for dynamic properties? If you're talking about pipeline, we are looking, evaluating ways to improve. So continue sending us feedback. We do take it very seriously. If you have a pain point, I hate having my customers not happy with things. Can you show an example of a working auto increment ID? Insert a row into a table with an auto increment ID, and then grabbing that value to insert into another table. I think you're talking about the surrogate key transformation, like right here. It's invalid. So I have a key. And this start value, you could join in with other things. I guess I'm a little, pretty much you would append a surrogate key to incoming columns, and then from there, what you do is you would find the max of your other table and pass that in either via parameter or lookup. You just have to have some way to pass that in. There's no way to do it on write. You have to do it as part of your transformation logic. So if I go all the way to the right, now I see I have this auto incrementing key. By the way, these are super helpful. Thanks for doing these sessions. Happy to do them. We like trying to demoing features before they came out, making sure people know how to do them. We're going to try to do as many as we can. As Mark said earlier, we have one coming out for managed. Sorry about that. One coming out for managed VNet in the near future, and that'll also be super helpful. That's a really exciting feature that a lot of people are demonstrating, or a lot of people are excited about and have been using in our public preview. Any plans for implementing SCD? Well, if you want to implement SCD, you could, that's kind of Data Factory's wheelhouse right here. Actually, I have one right here, a completely generic, slowly changing dimension type 2. So I would just say go into the pipeline gallery here, search slowly changing dimensions and or SCD, and you'll get what you need there. And if there are no more questions, thank you all for your time today. It was great to have an engaged audience up here. Um, and feel free to reach out, comment in the chat, reach out to us on Twitter. I'm Big Data Dan. Mark is Chromer Big Data. We also have the Azure Data Factory Twitter we monitor a lot. Reach out to us on LinkedIn, over email. Lot of different ways to reach out to us. Mark and I do not like being strangers and love any sort of questions or feedback that you send our way. Positive, negative.